Hello all, welcome to my channel. In this class, we will be seeing some previous year gate questions and their solutions on this chapter on the subject Signals and System from the topic Basics of Signal and System. In this topic, we will be covering some basic questions from Signal and System. Okay, so this is our first question. This is from Gate ECE 2023 question. So the question is like, let MT be a strictly band limited signal with a bandwidth of B and energy E. Assuming omega naught is equals to 10B, the energy of signal MT cos omega naught T is. So now there's some signal MT which is in time domain is given to us. Now, if we see this term band limited, that means what? Band limited is a term used when we are talking in frequency domain. That means we have to convert this signal into frequency domain and having bandwidth. So only frequency signals have some bandwidth. So we will be converting this signal into the frequency domain, and according to the question, the given signal is band limited with B hertz. This is in frequency domain. Now I have converted this empty signal into its frequency domain. I am taking omega x's. Now, how we find out energy? Energy is equals to 1 by 2 pi minus infinity to infinity m omega whole square d omega if we are calculating it in omega. Otherwise, if we want to calculate it in frequency, then it will become integration from minus infinite to infinite mf whole square df. Since the question given here is in terms of omega, as we can see cos omega naught t, so we will be continuing in terms of omega only. I am assuming the amplitude of this m omega signal to be 1. Now, let's just find out the energy of the signal. So, energy of the signal, above signal will become 1 by 2 pi. The signal is 0 from minus infinity till minus b, and it is 0 from b to positive infinity. So, it is present in between minus b to b, and value of mf in between these values is equals to 1 square d omega. If we solve it, we will be getting value of energy is equals to b by pi. So if we calculate the energy of empty signal, it becomes b by pi. But this is not what the examiner is asking. Examiner has told us that the value of energy of MT is equals to some E. What will be the energy of this new signal MT cos omega t? So we know that, let's say this new signal is equals to YT is equals to MT cos omega naught t. So if we convert this signal into its frequency domain, we know from the property, if we multiply cos signal in time domain, it will shift the signal by omega values in frequency domain. So y omega will become half of m omega minus omega naught plus m omega plus omega naught. So this is the property we will be using. So our signal was like this. because we are multiplying it with cos omega naught t, it will shift with omega naught value. Here, omega naught is given as 10b. So, the signal, new signal by omega. So, this 0 will shift to 10b and minus 10b. 10b and minus 10b. This b will become plus 10b, total 11b. This will become plus 10b, total 9b. So here the signal will be like this from 9b to 11b, and similarly in negative domain from minus 9b to minus 11b. What about the amplitude? So its amplitude was 1, it will become half. So it will become 1 by 2. Now let's just calculate energy of Yt. 1 by 2 pi integration minus infinite to infinite y omega whole square d omega. Here the signal is 0 from minus infinite to minus 11b, and it is also 0 in between this range, and after this it is again 0. So if I open this complete infinite brackets, so it will become from minus infinite to minus 11b, its value is 0. From minus 11b to minus 9b, its value is 1 by 2. From minus 9b to 9b, its value is 0. And again from 9b to 11b, its value is 1 by 2. And because of energy formula, it will be whole square. Again, from 11b to positive infinity, its value is 0. So if we solve this, this is 0. This is half square, that will become 1 by 4, and this will value will become 9b plus 11b. This is again 0, 1 by 4, 11b minus 9b plus 0. If we solve this, we will get energy of the signal yt will be equal to 1 by 2 pi 1 by 4 into 2b plus 1 by 4 into 2b. If we solve this, this energy will become b by 2 pi. We can write it like this, 1 by 2 b by pi. If we clearly observe this, the energy of empty signal was b by pi. So I can write this since it will be equal to E. So new energy will be equal to half of the energy of empty signal. So option B will be your correct answer. Moving on to the next question. The question says that consider the signal ft is equals to 1 plus 2 cos pi t plus 3 sin 2 by 3 pi t plus 4 cos pi by 2 t plus pi by 4, where t is in seconds. Its fundamental time period in second is. So in order to find out the fundamental time period of this whole function, we need to find out the individual time periods. So this is a function having four different variables. So ft is equals to 1 plus 2 cos pi t plus 3 sin 2 by 3 pi t plus 4 cos pi by 2t plus pi by 4. So this is 1. So 1 is a DC signal. Time period of DC signal is considered to be 0 since the frequency of DC signal is infinite. So time period of this DC signal will not hinder the time period of any other signal. So basically, whenever we are calculating the fundamental time period of a additive signal, so we can ignore the DC signal. Next signal is 2 cos pi t. So now we have to see what's the omega in this. So how we write a cosine signal is cos omega naught t. So omega 1 is equals to pi 3 sine 2 pi by 3 t. Omega 2 is equals to 2 pi by 3 and 4 cos pi by 2t plus pi by 4. This is also a phase. So this is not our omega signal. So omega is just this before t. So omega 3 will become pi by 2. In order to find out the fundamental time period, we have to find out the fundamental frequency first. Fundamental frequency. So omega naught will be equal to, we have to find out greatest common divisor of pi 2 by 3 by 2 pi by 3 and pi by 6. Basically what we have to find out is HCF, highest common factor, or you can say greatest common divisor. So the greatest common divisor among all these three will be pi by 6 only. So when we know the fundamental frequency, we can easily find out the fundamental time period. Fundamental time period will be equal to n equal to 2 pi by omega naught. So equal to 2 pi by omega naught is pi by 6, so it will be 12. So option B will be our correct option. So this is how we calculate fundamental time period in very easy way. So you have to find out the individual fundamental frequency, find out the total fundamental frequency. So this is total fundamental frequency by taking greatest common divisor of all the frequencies, and then find out the time period by 2 pi by omega naught. Moving on to the next question. So next question says that let the input be u and the output be y of a system, and the other parameters are real constant. Identify which of the following system is not a linear system. So what is a linear system? Let me show you a block diagram in order to understand a linear system. So a linear system basically follows two rules. So first one is law of additivity and second one is law of homogeneity. What is a law of additivity? So when we have two signals, suppose x1t and x2t, they are input signal. When we pass it through a system and we are getting some output y1t and y2t and we add them up, so we get the total addition of the output that will be equal to y1t plus y2t. And this is the first way of doing this. Second way, if we add the input before and then pass it through the system, and then the output is coming as y1t plus y2t like before, then this type of system will be known as satisfying law of additivity. And if it is not equal to this, then it is not satisfying law of additivity, right? If you are checking law of additivity and it fails, that means the system is not linear. And if it passes, then you have to check for law of homogeneity as well. Now, what is law of homogeneity? If you are having a system xt and you passes through the system and you get some output yt, and then you multiply that output with a constant k, you get some output as kyt. Here k is a constant. Or this is the first way, this is the second way. You multiply the input with constant k, you will get kxt, and then you pass it through the system. If output is equals to kyt, that means it follows law of homogeneity. And if it is not equal to kyt, then it does not follows law of homogeneity, right? So this is how we check for linearity of a system. We have to check for both law of additivity as well as law of homogeneity, right? Now you check for the systems. Here, this option A. So this option A is nothing but a linear differential equation. Why we are calling it linear already? Because it is the power of 3, power of 2, power of 1, and then a single variable. Here also it is a linear differential equation. Linear differential equation. So this is already linear. Now, one rule, if I tell you, all the differentiation and all the integration, they are linear system. Okay, so they both are linear system. Now we have to check for this. Now this kind of system. Let's just check this system for law of additivity. Now law of additivity says that if I am taking this y1 is equals to a u1 plus b, right? And y2 is equals to a u2 plus b. Now we will be passing it through the system. Let's just add them both, pass it through the system, and whatever output we are getting, let's just add them both. So adding them both, y1 plus y2 will be equal to a u1 plus b plus a u2 plus b, that will be equal to a u1 plus a u2 plus 2 of b. Otherwise, what we can do is add them first, add the inputs first. So adding the inputs first means what we have to do. So input here is u1 and u2. So y1 plus y2 will be equal to a u1 plus u2 plus b. So that will be equal to a u1 plus a u2 plus b. So basically they both are not equal. They are not equal. So that means it is not following law of additivity only. So this system is a non-linear system. And if we check for this system, it is a linear system because a constant multiplication before any input or output does not change the linearity or does not affect the linearity of the system. So scaling also doesn't affect linearity of any system. Linearity of any system, right? So this is how we check for linearity of any system. We have to check for both law of additivity and law of homogeneity. If law of additivity does not satisfy, there is no need to check for law of homogeneity since that system will automatically be a non-linear system, right? Moving on to the next question. So next question says that the input xt and the output yt of a continuous time system are related as this. The system is what kind of? Now it is asking us to check for two things, linearity and time invariant or variant. So this is a integral. So we know the integral will be a linear system. So these two options are directly discarded only. So we have to check for time invariance and time variance. So how we check for time invariance and variance? We know that xt is input and yt is output. So if we pass xt, so this is first thing. So this is first way, this is second way, how we do it. So if we pass xt through a system and then delay it by t naught, if we are getting output like this. Other thing, we delay input only by t naught and then pass it through the system. If both are same, then the system is time invariant. If both are not same, then the system will be time variant. Let's see how we do it. So we have a signal like this: t, t minus t, xu, and du. First thing what we do is delay the output by T naught. Let me write it here only. Delay output by T naught. So y T minus T naught will be equal to, instead of T you have to write T minus T naught, T minus T naught minus T, xu du. So this is what we are getting. Right. Now, second thing, we have to apply a delayed input. Delay input by T naught. So T, T minus T, xu minus T naught du. Now we have to write input here only. So we can just say that, let's just keep T minus T naught will be equal to tau. So the system will become T minus T naught, T minus T naught, the limits will change, and this will become x tau d tau. Now if you see, it is same as y t minus t naught. So this is what kind of system? If they both are same, so this is time invariant system. So option B will be the correct option. So this system is a time invariant system.